User. We need to close. All right. Anybody else? Anybody else? Anybody else? All right. Okay. So we have IP addressing, we have private IP address, public IP address. What is the difference between private IP address and public IP address? What's the difference? What's the difference between private IP address? See, no answer is wrong answer. I don't have kin. This is not Nigeria. It's just give your own input.
Yes. I
So
think the
what's the
pri-
difference?
I think the private
Yes,
one
continue,
is
Mr.
actually
Mr. Tayo. Sorry, sir.
I
I did.
think the private one they normally use it within an organization, a closed setting, where the public one is probably the regular one we use that actually do or do that is more of that is outside the private organization and all that.
Thank you very much, sir. So private
Yeah.
IP address is not routable on the internet. So either organization or family, business, there are IPs that are not routable. That means they can't go on the internet. So what happens is that you have something called NAT, Network Address Translation. Please know that. You will need to know that one. Anything you are doing in IT, no NAT, Network Address Translation. It NAT, it's pretty much will NAT your public IP to your private IP, excuse me, to a public IP address. So you need to know what's called network address translation, and you have it in your house. When you get your internet box, your modem, your internet service provider, your ISP provides you with a one public IP address. So if you have 10 devices in your home, your husband, your wife, your children, their cell phones, iPad, TV, fridge, anything that connects to the internet, you know, that will go through, it will have private IP address. Now, if I'm going on google.com, it's going to NAT it from a private IP address to what? A public IP address. That's it. So in most cases, you can't assign 15 public IP address to a home. So in most cases, most ISPs will assign one public IP address, while everything else, the router will give private IP address to everybody in the home. Everybody will have a private IP address. You have a ring camera in your house, private IP address, everything. But when it's now nothing to NAT to a public IP address. So that is it. So private IP address is not routable on the internet. It will not work on the internet. Public IP address is routable on the internet. That's what the difference. Private IP address is not routable on the internet. Public IP address is routable on the internet. And there are several examples I can give. The 192s, the 172s, those ones are private IP addresses in most cases. And then, of course, public IP addresses are different numbers 42.32.50, 25. You see that it is not the same as private. In most cases, private IP addresses are three numbers 172, 192 dot something. While public IP address can be like 52.70, mostly two. You guys will get to know it. Just know that TCP and UDP, TCP is more dependable. It has to get confirmation. So if I'm TCP, let's say I'm going to buy something at Walmart or Publix or I don't know anywhere you go. When I go there and I buy, the cashier will give me a receipt. That is TCP. That means that the cashiers acknowledge that I bought something. Just in case I want to return it, I can go back and say, "This is my receipt. This is what I want to return." Why UDP is not dependable? Why? Because it doesn't care. It just sends the message out. It doesn't show if it's been received or not. So TCP takes more than UDP. That's why live streaming uses UDP. Because UDP, if I'm live streaming now on Zoom, I believe that you are receiving it. If you're not receiving it, go and check your ISP, check your internet. I am zooming, like for my end, I am broadcasting to you on Zoom. So UDP is what is being used, I believe, because UDP does not have all the confirm. So I don't have to confirm if Mr. Nido is online. I don't have to confirm if Mr. Shola is online, or Sister Luwashin is online, or Ebenezer is online, Mr. Ebenezer is online. I just know that you are receiving. If you're not receiving, then go and check. Now you cannot say, okay, you can pick me and say, sir, to be honest, I don't think I can hear you clearly. Your voice is not clear. You're on mute. Now that's TCP. You are giving me feedback. But if you can hear me clearly, you don't have to tell me anything about hearing me clearly or watching me. You can see. If you're watching live stream of your church, maybe you are somewhere and you're watching midweek service or you're watching the church service, they're not going to ask you, can you hear? No. We believe that as we are live streaming to you, you can see us and you can hear us. Now, that is UDP. Now, TCP is like, okay, something's happening to the audio. So we now put on the chat or in the comment section. We cannot hear. That's TCP now. Because you're not giving feedback to the technical team. We can't hear you. But if you can hear, you won't put anything there and say you can't hear because you can hear me. So we know that you can hear. Hope that makes sense. I'm just giving an example that TCP there has to be some level of acknowledgement that something has been received. Why UDP? If you receive, you don't receive, that's you. So UDP is mostly used for live streaming. Live streaming is UDP. YouTube, UDP. Zoom, I believe, is UDP. So it's mostly like that. So there has to be a confirmation, and we'll go into that. Then, of course, port numbers. They both allow communication. They do. It's not that TCP does give an acknowledgement. They both allow TCP does acknowledge that okay, the message has been sent. It's like when you go to the postal service and you send something and you now ask them that they should sign that they've received it. That is TCP. UDP on the other hand, they don't have to. If they want to receive, they don't receive. There are some things that I mail. If you receive it, I know that if you have not received it, then you let me know you have not received it. Hope that makes sense. So that's the difference between TCP and UDP. You should know those. Port numbers, know it. The main ones, port 443. What is that? Please put in the chat. Port 443. I just put some and let me know what it is. Port 443. What is that? What is that? HTTP. What is that? DNS. What is that? Port 25. What is that? See, I mix it up in a way. So port 443. What is that? HTTP. What is the port? So please put in the chat or raise your hand. What is it? What is port 443? What's port 443? Please post or answer. It's very this one is easy stuff. Oh. What's port 443? Okay, that will be your assignment. I'm not going to give the answer because is very basic. So I'm not going to give the answer. Do your research. But let me let you know anything I'm emphasizing is very necessary. Necessary. These port numbers I'm giving you, you will work with them. For those that are going to do IT, you are going to work with them over and over and over again. You should just know them at the back of your easy hand or back of your head, or I don't know by heart. Port 443, port 80, port 53, port 25. I just give some of the answers. You should know them because it will come in handy. Now, for those that are going to do like maybe firewalls, they will give you, in most cases, the way it comes in when you get the ticket. So there's something called service now. I'm just putting it because I don't have a blackboard. So forgive me. So service now or Jira. GI, not Jehovah Jireh. Jira is Jira. Jira, I don't know what it's called, but it's Jira. So those are ticketing systems that most companies use. Most people use ServiceNow, or they use both ServiceNow and Jira. Some people have other ones, but those are the two that the people use. There are other ones that people use, but ServiceNow, what you get is that as you enter into the company, you get the job. So of course you will be connected to ServiceNow, and what you will see in ServiceNow is different from what I will see. So if I'm a firewall administrator or a firewall engineer, my own board will be different from someone that is just a regular employee of the company. Hope that makes sense. Because from my perspective, I should be seeing all the tickets. From the employee's perspective, they're just submitting tickets. I hope that makes sense. So in most cases, for those that even work in regular jobs, based on your job description, there's some level of access that you have. If you're in accounting, there are some files you can see that somebody in HR may not be able to see. I hope that makes sense. That's division of labor. Most companies have it. So if I'm in the executive team, let's say I work with the CEO, there's some things I will see that if somebody is in, I don't know, maintenance, they won't see because it's none of their business. I hope that makes sense. So there's some level of access that they give different people in their offices based on your job description. Now, even in the same place, you can be a firewall administrator and have some access. If you are a firewall engineer, there's another access that you have. You can have access to the back end of things compared to other people. Hope that makes sense. That the more elevated your work is, the more access you have. So the more you work you have, if I'm an architect of a company, I'm talking about the network architect, you have to be able to see everything from a bigger point of view. So you have access to more things than a firewall administrator or a firewall engineer. I hope that makes sense. Please, thumbs up. It makes sense. Good. So service ticket. So yes, I mean service ticket. So what happens is that if I am Victor and I need access, let's say I need access, I am working as a developer. I need access to a different server. And I know that in most cases, most companies have firewalls. And what is the job of a firewall? A firewall blocks access. A firewall is configured to block access. It is the job of the firewall administrator or the firewall engineer to allow access. I believe that makes sense. It's the job of the firewall administrator. So, in general, the job of the firewall is to block access. So I know that I'm doing a developing work. Let's say I have to create an app for the company. I have to work something on the website. Maybe we have to add something to the website of the company. As a developer, I don't have access to the firewall. So what I will do is I will create a ticket. And what will I put on that ticket? I'll put the source IP. The source IP, I'll just give an example. Give me is 10.45.67.0/24. Then, excuse me, I wanted to do, I don't, destination will be 42 or 43.23.45.67. And the port number, they put port 443. This is how everything will look like. So it will look like this. When they put in the ticket in service now, you will see the source IP address, the destination IP address, and the port number. And that's how it is on every firewall. Now, because I have a firewall here, I can't share my work firewall, but I can at least share what I put on the chart. So you have, in most cases, they are going to give you the source IP, destination IP, and the port number. And that's how it is on the firewall. When you log into the firewall, so when you start your job, they will give you login access to the firewall. When you log in, it's the same thing. You will see source, destination, port, and allow or deny. So in most cases, when you get the ticket, you put in the source IP address, which is what you see there. Am I right? 10.45.67.0/24. On that tab, on the destination tab, you put in 43.23.45.67. On the next tab, you put in the port number, port 443 or HTTPS. Then it will say allow or deny. You choose one. Click allow because you are not denying access, you are allowing access. Am I right? So they ask you for access, not to deny the access, to allow access. You click allow. Some other ones, for accountability purpose, for PCI, that's, we have auditors that come in. You put in the ticket number. So the ServiceNow ticket that was given to you, some do it. It depends on the company. Every company is different. The ServiceNow ticket, let's say it is 3456. I just put that there. You put it. There's a place for comment in the firewall. You put 3456. Some they will ask you to put your name. So you put Victor Tikobo and put the date. It depends on the company. 11 09 20 2025. Those are an example. Some like there's a company I work for, you don't have to do all these things. You just put in the source IP, destination IP, and port number, you are good. You get what I'm saying? That's the another company. Some other companies, they will make you put in the source, destination, port, put the ServiceNow ticket, and put your name. It depends on the company. They will let you know. That one they will teach you. Just know that when you open the firewall, Palo Alto firewall, Checkpoint firewall, FortiGate firewall, it has the source IP, destination IP, and port number. That one will be there. Now, the other extra ginger, it depends on your company. Some companies want you to put in the ServiceNow ticket and put in your name. It depends. Some don't care. You get what I'm saying? Depending on PCI. So it means that means that if you put in your name and the ticket, if the auditor comes and look at that rule, they can trace it to you and say, okay, this rule you put in, or trace to the person that put in the rule. That's the ServiceNow ticket number. You get it? So the call to allow or deny is based on in most cases you are allowing, because the firewall naturally is configured to block. So when you get the ticket, they will say, please, we need access to this. Now we have block. So in terms of blocking, in most cases I've done 98% allow and 2% deny. In deny is mostly that we have a bad actor. So that means that we see that somebody is trying to hack our company. So they will say, please put in the same thing. They'll give you the source and destination, and they will say, do what? Deny. That means deny this person from accessing our company data. So in most cases, I would say I've done 99% allow and maybe 1% deny. It's very rare. And when you want to do deny can also be in other tools like the web application firewall. It can be in the this other tool again. There are other tools that can deny traffic too, not only the firewall. But in some cases, they will say, you know what, do it on the firewall. So if you do it on the firewall, you just go put in the source, destination, and click deny. But in most cases, you'll be doing allow. Go ahead, Mr. Aditayo. Sorry, I can't hear you, sir. You are muted. I still can't hear you. Sorry, maybe it's just, maybe it's in me. Maybe I'm wrong. I can't hear you, sir.
Can you hear me now?
Yes, I can. Yes, sir.
Okay. I'm actually thinking about the deny allow stuff like that. I tend to wonder because you mentioned about the hacking, you know, this guy, the way they actually do things, maybe, I don't know, maybe they send out messages in the way that is going to keep on hacking. But in this firewall, that actually do that has the responsibility of denying or actually accessing probably the network. Is it something that the person in charge is going to be there, like a security person who is watching the CCTV cameras all around to know that okay, this thing has come, I have to deny it, or it has been set in an auto mode that once it actually do a pick that is coming from the hackers, it automatically is going to deny without anybody actually sitting by the maybe his computer to actually check on the activities, online activities, and all that. I really want to know.
Great question. So in every company, there's division of labor. So in most companies, they have people that monitor. Their job is to monitor the logs. Your job is to put in access. If you are doing firewall, your job is to allow. So if I bring a ticket to you, your job is just to put in the ticket, do it, push it, and close the ticket. When you close the ticket, you send the email to the person, and the person will know that okay, my ticket has been worked on. Same thing. There's some people that their job is just to monitor the logs. Anything that comes to the company, they can flag it. So when they flag it, they can now one thing report it to their supervisor or send it to you and say, hey, by the way, we see this bad actor. We want you to block. You know what I'm saying? So it's not as if you sit there in front of your firewall and be looking, hey, this one, you don't have time for that, it's too much. That's none of your business. Your own job is to put in the work. Now they can demand that you do it. And if that's to do it, what they will do is that they will give you a change number. Let me put that in the chat. Change number. Change number. It's also a service now ticket. So everything is a service now. A change number. That change number is what you will use to make that change. A change number. In the access control department, there are different departments that monitor logs. Their job is just to flag. They are just looking, and they have some that they can flag. If they see something coming from a country, they even flag countries. For those that are from Nigeria, there are some companies that flag Nigeria because they have no business there. So they flag different things. China, Russia, they flag some countries. If something's coming from there, they say, hey, this is coming from China. Do you have any customers there? If they say yes, who is the customer? They can go in the back end and confirm that, okay, this is a legit customer. If a bad customer, they'll just tell you on the firewall, block it. And they'll say, this is the source IP, destination IP, and this is the change number. I'm saying it because I've gone in situations where you don't, and some companies they will let you do it without change number. But if possible, you will ask the person, I need a change number. I do. So that they will not put the thing on you. Because sometimes it has happened where people go and block legit customer. Maybe you go and block Google, or you block Microsoft, or you block Tesla. Let's give an example. And they now said, oh, Victor, God forbid, or somebody else blocked the customer. It did not be on you. So when somebody asks you to do something like that, you say, okay, thank you, but give me what? A change number. They'll say, okay, we are working on it. And in some cases, they will spin up a meeting. This is the back end with the emergency team and create a chain number and give it to you and say, okay, this is the chain number, work on it. And in most cases, you cannot even confirm. If you're not sure, confirm with your supervisor. This person sent this to me. What should I do? It's best to ask questions than to just act impulsively. I'm telling you from personal experience, it can be very painful. So just learn from my mistake. When you are, especially with deny, confirm with your supervisor if possible. I got this ticket. Should I do it? They can give you, okay, in the company, do it or hold off. Let me do my research. So confirm with your manager, confirm with your supervisor. That's what I would say. If all else fails, confirm with them before making any kind of decision in that area so that you're not getting in trouble and they are putting blame on you and they say it's village enemies and it's just a stupid mistake. Forgive me. So that one I would say you should work on. But in most cases, you get the source IP, destination IP, and port number. Let me ask, that source IP I put, is it a private or public IP address? Don't look at the chat. The source IP I put there, is it a private or a public IP address? Yeah, you're on mute, sir.
Is it not private?
Yeah, it is. It's a private IP address. In most cases, the 10 dots are private. The 172, the 192s, in most cases, are private IP addresses. That's a private IP address. Now, that destination, is it a private or a public IP address?
You now say it's public, right?
It is public IP
Public.
address. In most cases, when you say number like that, is public IP address. So it is the public IP address. So you can see that that's like, so when you get that, you put in the source, the destination, and the port number. That's it. Allow, deny. In most cases, you'll be allowing. Some companies, as I said, they will say put in the service ticket, put in your name. Some they will say just put in the ticket. We can trace it. So every company is different. Some companies are not really stringent on PCI. Some are very stringent on PCI. So if your company deals with customers and they collect credit card, debit card information, they do it. This is what's called PCI. PCI is something that has to do with audit. I don't know the acronym, but when you start hearing PCI, that means that they're going to audit your stuff. Now, if you work as an administrator, that's none of your business, because if you work as a firewall administrator, the engineers will deal with so the higher you go, the more you have to deal with bureaucracy. So you deal with all the other stuff that comes with it. So you're not only dealing with your technical aspects, you're also dealing with the other stuff, which is like audit. I'll leave it as that. Let me share my screen. Anybody have any questions or comments? Please learn port numbers, private and public IP address. Know the difference. TCP UDP, know the difference. Port numbers, know the main ones. Port 443, port 80, SMTP port 25, DNS port 53, SSH port 22. Know those ones. Those ones you will see them over and over. The other ones that you will see, but those are the ones that I've seen mostly in my experience. IP addressing and subnetting. We have 4 octets. Remember, we have 4 octets. Am I right? We have 4 octets. Is the fourth octet that lets you know if it's a /24/32. Remember that it lets you know. So that is what we should also look at in that area. Let me share my screen. Share. I hope you can see my screen. I believe you can. Okay, so look at it. You see that public IP address are not usable or routable on the internet. Private, no, public IP address are usable on the internet. Excuse me, they are usable on the internet. Private IP address are not routable or usable on the internet. So for you to use your private IP address, what does it require? NAT, network address translation. It helps you to connect to the internet. In most cases, right now, you are using a private IP address on your laptop, on your phone, that is nothing to your public IP address provided to you by your internet service provider. Yes. And if you look at it, the private IP address, you see that we have 10.0, see it, 172.16 and 192. Those ones, in most cases, if you see them, they are private IP addresses. The other ones, 24, for the other ones are public IP addresses. You don't have to know those ones for interview. At least I've not been asked what is the private IP address, the public. It's just good to know when you are working in as an IT engineer or administrator, to know the difference between a public IP address and a private IP address. I've had situations where I was asked to whitelist an IP address. What is whitelisting? I've asked that, what is whitelist? Someone put that in the chat. What is whitelisting? To whitelist or blacklist. What is blacklist? What is whitelist? That should even give the, if you just put it together, you should give a definition already. What is whitelisting? Sister Oluwaseun, what is whitelisting and what is blacklisting? So we can also post on the chat. Mr. Shola, what is whitelisting and blacklisting? Let me check the chat. Move. Hey, hold on 1 second. So let's see. Thank you. A whitelist is to allow access, blacklist is to deny access. I hope you can see my screen. Whitelist is to allow access, blacklist is to deny access. So from this, you can see here that when someone says whitelist my IP address, that means that we want it to circumvent any controls that you have. So in most cases, you also there's a place where you can whitelist IP addresses. That's a different one for a different day. But if you work in a web application firewall, on the firewall, there's a place where you can whitelist. Now, to whitelist an IP address on the firewall, you just do allow, pretty much. You just allow the IP address or put it in a group. So whitelist is to allow access, blacklist is to deny access, and blacklist is for like bad actors, malicious content. You are not sure what it depends on to hack your company, you blacklist their IP address. So that's it in terms of that. Then of course we look at the fact that there are 4 octets, 4 octet IPv4, 4 octets, and each octet tells you, of course, I'm not going to look at class 1 and classless. Look at that one later, if you want to. So we have classful, we have 4 octets. This thing is blocking my view. Excuse me. I don't know. Okay, so we have 4 octets. The class full address, you can see there that we have 4 octets, which is the 192.168.1.0. You can see that the first 3 octets, one is the network and one is the host. One is the network, one is the host, depending on which one you're looking at. So, well, do you need to know it if you want to? Sure, but I've never been asked in the interview what is a class full or classless address. As I said, the class is to train for interview. The rest you will learn on your own. That's how I was trained. Those people you learn on the go. Because if you want to really sit down and learn IT, it's going to take you years. Let's be honest. It's not something you can just sit down and learn in. So the way you get trained is just like you pretty much train for interview. It's like maybe you're a sprinter, you train for a race and you go and eat a bar and amala afterwards, pounded yam. So before the race, you just eat light food, eat leaves, eat salad, all those things, run, train, exercise. Then after, okay, I'm good. So that's the same thing with these classes. Even if you do a 6 months training, you can't really cover everything in IT because it takes years, and most of the time you have to learn. I learn by experience. I'm more of like a learner. I have to touch it. That's me. I have to keep doing it to learn. That's just me. So when it's just theoretical, just put it on the class board, I have to work it. I have to do it for me to now know and internalize some of the things. So that's just me. So that's how it is here. You just learn to beat the gate man to pass the interview. When you enter, then they don't help you. All right. MAC address. MAC address is like the layer two. It's pretty much every company, every laptop has a MAC address. So it's an identity for your laptop. Every company, I say every company, every laptop has a MAC address. Is assigned to you by your vendor. It's like how your car has what's the other number for the car again? Your car has that if you are trying to look up your car, I forgot the name what you call it, but your car has that same thing with your laptop. Your laptop also has it. So that's how it is. So tag number, those other things. All right. So local area network, wide area network. We've talked about it. Local area network is local from one host to another host. You can see that both host A and host B are private IP addresses, so you can do it locally. And then of course, TCP UDP and TCP built connection. UDP is connectionless. TCP is reliable. UDP is not reliable. You know that. If you can answer those two, I think you're good. The rest you can put there, but TCP is reliable, UDP is not reliable. Examples: UDP is more of live streaming, TCP is more of like sending email or maybe sending stuff like that. Um, Sending data, UDP does there's no acknowledgement. Why with TCP, when you send data, there's an acknowledgement that it has been received. That's the difference between TCP and UDP. Um, yep, let's keep it moving. Now, there's something in terms of TCP. So when I send a packet from my laptop, let's say to Mr. Ebenezer's laptop, so when it goes through the line, it goes through the internet, and it goes to Mr. Ebenezer's place, he will acknowledge it and says, "Yes, I've received it." You get what I'm saying? So that's what it's called scene arc. I'll put it in the chat. This scene arc. I don't know why my mouse is not working when I do it. It's scene arc, scene arc. Let's put that in the chat. Go and watch videos on it. It's very you see 2 minutes videos on it. Scene arc. So basically, when I send a message, you know, it goes through the back end, it gets to Mr. Ebenezer's place, then he will acknowledge it. If I send a message to Mr. Ebenezer and he doesn't acknowledge it, it will come back to me as void. That's TCP. So if I send something to him, thank you, VIN, Mr. Nido. Thank you, sir. It's VIN I'm talking about. Thank you. If I send something to him and he doesn't acknowledge it, to come back to me as it's not working. So in most cases, when you even create rules on the firewall, what happens is that when you have implemented the rule and you close out the ServiceNow ticket or Jira ticket, what happens is that sometimes people will come and tell you that what you have done, it is still not working. I've mentioned this before. What will you do in that instance? You go on the firewall logs. Firewall logs. Some is inbuilt into the firewall. You just click on monitor. There's some place where you just click on monitor or you click on logs. It's there. So the firewall has different tabs. One of the tabs is where you put in the firewall tickets. Another tab is NAT. Another tab is the logs. It's inbuilt into the firewall. You just click on the logs. And what will you do? You put in the source IP, destination IP, and specify the time. Maybe in the last 24 hours, in the last 12 hours, the last 6 hours, last 2 days, last 1 month. You click on that. When you click on it, it will show you if anything is hitting the firewall. Let me repeat one more time. You get a ticket, you implement the firewall ticket, which has the source IP, destination IP, and what? The port number. It has it. You've done it, you've closed the ticket, the person gets an email on their end that their ticket is complete. They test it and it is not working. What will you do? You go on the firewall logs, and in most cases, inbuilt into the it's just a different tab on the firewall. As you have the place where you put in your source and destination IP address, there's another tab where you check the logs. On that tab, it has what? Source IP, destination IP, and port number, and the time period. What's time period? The thing can go back 1 day, go back 3 days, go back 7 days, depending. You get what I'm saying? So you put in the source IP, the destination IP of that person, and the port number, and you now say, okay, go back 6 hours. So the logs will go back 6 hours to check if anything is hitting the firewall. You get what I'm saying? If you do go back 24 hours, same thing. The more days you put, the more time it takes. So you put go back 30 days, it will take more time. You get what I'm saying? More time because it is going back the amount of days. If you say go back 2 hours or 15 minutes, that's easy now. So you go back 15 minutes and check. You get what I'm saying? So you go back and check what? The firewall logs. In the firewall logs, you will see it. So when you check, in most cases, if you don't see the firewall denying traffic, if you don't see anything popping up on the logs, it is not your fault. You are putting the firewall rule, their server is not working. This is where you see the TCP window. So the server are sending a packet, but either the destination server is not receiving the packet, but on your end, when you check the firewall, nothing is showing that it is getting blocked. So you let them know that nothing, the firewall is not blocking your traffic. We are not seeing anything on the firewall. Go and check your server. That's what you will say. That's your answer. Go check the server to make sure that it is sending packets. That's all you say. And this is the reason why. Because you have something called SYN ACK. What is SYN ACK? SYN ACK is that you send a packet out. The receiver is saying, I'm not receiving it. Hope that makes sense. Any questions before I move on? Any questions before I move on? So what is SYNAC? It is a three-way handshake. So this is what you put when you are watching videos. It is TCP. I don't know why this thing is doing. TCP three-way handshake. But see, there's some videos I've still people to watch and they've not watched it yet. The thing about each class, we are building on top of it. So if you are not getting one aspect of it, it might confuse you later. So please watch these videos. They are 5-minute videos, 3-minute videos, 10-minute videos. It's not anything long. It's not 1 hour. TCP three-way handshake. What is TCP three-way handshake? It is syn or synchronize. Sorry. Syn or I'm just putting it in the chat. Synchronize. Synchronization. Synchronize. Syn. So I send a packet from my server. I initiate a connection by sending a SYN packet. A SYN packet. I initiate connection by sending, please check your chat, that's why I'm putting everything. Sending a SYN packet. This says, I would like to have a conversation with you. You get what I'm saying? So my server is sending a SYN packet to another server. I would like to have a conversation with you. Then there's something called SYN ACK. SYN ACK or synchronize plus acknowledge. SYN ACK. So the server, I have sent a SYN packet to another server. I would like to have a conversation with you. If that packet wants to have a conversation with me, what would the other server say? The server will say SYN ACK. That means that yes, I have received your request and I would like to communicate with you. That is SYN ACK. That makes sense? Then the next thing is ACK, acknowledge. Acknowledge. That means now that you have told me you like to have a conversation with me, then I've acknowledged that, okay, we are good to go. It confirms the server's response. It confirms the server's response. I hope that makes sense. So, three-way handshake in TCP, what does that mean? TCP, three-way handshake. A server, server, it can be a Windows server, whatever server it is, sends a request, a client server sends a request to another server. I would like to have a conversation with you. I would like to send packets to you. That destination server will now send SYN ACK. I have received your request. I would like to communicate with you. Then the client server will now say what? Acknowledge. Okay, thank you. Let the initiation begin. Everybody, that makes sense. SYN ACK. That's it. Synchronize, acknowledge, and acknowledge. So people say SYN ACK. So number one is what? SYN, not SIN. Number two is SYNACK. Number three is ACK. Does that make sense? SYN, SYN. A client server sends a packet or hello to a destination server, to another server. I would like to have a conversation with you. That client server or the destination server is like message received, SYN ACK. I want to have a conversation with you. I've received your request and I grant your request. Then the client server will now say, acknowledge, thank you very much, and send the packet to the. Oh, that makes sense. We have the client server trying to talk to a destination. It's like you calling and saying hello, hello, hello. The person on the other line says, how are you? How are you doing? I'm acknowledging that you are calling me and you are saying hello, and I'm acknowledging your voice. Hope that makes sense. Then SYN ACK is okay. I've acknowledged okay. Then ACK is okay. What do you want to say? Why are you calling me at 2 a.m. in the morning? Hope that makes sense. SYN ACK, SYN ACK, and they can answer in the interview. That's why I'm putting it there. TCP three-way handshake, especially if you are doing something called network engineering, you or network administrator, you need to know this. So anything I put on the chat, please go and watch videos on it. Go and watch videos on it. Three-way handshake, TCP three-way handshake. Can somebody describe it for me now? I've mentioned like 3 or 4 times. Describe it in your own way. If I'm interviewing, okay, what is TCP three-way handshake? Welcome, Mr. or Mrs. Let us start off with the interview. What is the TCP three-way handshake? You can unmute yourself or put in the chat. What's the TCP three-way handshake? Something like that. It's just a way of how do I say it now? Initiating connection between one server and another server. See, anything we do in the backend, you are dealing with backend stuff. So I can be going on google.com. My ISP sends a packet to the Google server. And you know that each server around the world they are different. If I'm in Singapore, the server I'll be accessing is different from the server I'll be accessing in Georgia. You know that Google has different servers around the world, different data centers around the world. So if I'm in Singapore or Malaysia and I put in www.google.com, on the back end, I've sent an initiation from my own laptop, from my own server to Google and say, give me the interface. I want to check my Gmail. I want to check my email. Am I right? So as I've sent the SYN packet to them, synchronized packet, the Google um, server sends me acknowledge. Okay, I acknowledge that you want to check your email. Then I say thank you very much. I sign in, put in my credentials, and I check my email. Hope that makes sense. I'm just breaking down for you. You can understand it. SYN, a client server, initiates connection to a destination server. A is initiating with B. B is saying, I have received your acknowledgement. You want to communicate with me? And B says, yes, you can communicate. That's SYN ACK. So A is initiation, B is response, C is A is saying to B, thank you. Let me send the packet now. Hope that makes sense. SYN ACK. Synchronize, acknowledge, and acknowledge. In most cases, they don't say synchronize, they don't say SYN ACK. If you don't know what SYN and SYN ACK is, that's a problem. Nobody's going to tell you what is synchronized. What is that? What the heck is that? It can mean anything. When you hear syn, SYN, you know that it's talking about the client is initiating connection to the destination. A is initiating with B. SYNAC, B is acknowledging that A has sent something. Then A is saying, okay, thank you for sending it. This is what I want to send to you. I hope that makes sense. So in most cases, when you are working on the firewall, you have something like this, where you have put in the rule on the firewall and they are still getting blocked. Why is it getting blocked? Because it's not you. It's not the firewall. It's their server. Their server has sent initiation packet to the destination server and they are not hearing anything. So they are saying it's not working because it's not a firewall issue. It's a server issue. Hope that makes sense. Please answer me because I will just keep moving. I know that you have gotten. If you have any questions, please ask the question. Some people are just quiet. Mr. Oluwaseun, Mr. Shola, I believe that you understand what I'm talking about, and you are also everybody's also focusing and So I don't want to say something and it's like it's not making sense to you. Thank you. Okay, thank you, man. Please just making sure that it's making sense to you. Syn, SYN. One more time. The A. Let's say I'm trying to communicate with Sister Oluwaseun. I will send a syn, SYN, to Sister Oluwaseun. I want to send some packets to you. She will acknowledge and say, thank you. I've received your request. You can send the packet. That's syn arc. Then I will now reply and say, okay, these are the packets I want to send to you. Hope that makes sense. Syn arc, and arc. That means there's some. That's why TCP, there's has to be a confirmation. That's why TCP takes longer. That's why TCP is more dependable than UDP, because TCP is saying that I need to get your okay and get a affirmation that you have received what I'm sending to you. Hope that makes sense. Syn arc, and arc. That's how it is there. I put it in the chat. Oh, Mr. Okay, syn initiation, thank you. Syn arc is acknowledging and acceptance, thank you. And arc, thank you. That is it, Mr. Nido. That is how it is. So please, I will hope that you should watch videos on it if you don't understand it, but it's very straightforward. I am sending a packet to somebody in destination. The person has acknowledged that they've gotten the packet, and I say, okay, this is my packet. That's it. Syn arc, and arc. SYN. A or client server initiates packet. B, number two, syn arc. Destination server has acknowledged that you are sending a packet to him, and he's saying thank you for sending it. And A is saying, okay, these are the packets I want to send to you. That's it. Hope that makes sense. Thank you very much. I believe that you got it. If you don't, just watch some videos on it. Now, we're looking at subnetting. Now, I don't want you to be confused. Subnetting is very essential for IP addressing. So when you have an IP address, you have a subnet for it. Now, as I put there, that /24, there are other IPs that are attached to it. /32, that means there's an okay, let me give an example now. Just to jog our memory so that what is okay, let's do 10.12.45.34. Is that a /32 or /24? Excuse me, forgive the typo. How about 10? Thank you very much, Mr. Ebenezer. 12.45.0. I will put the 5.0. Is that a /24 or /32? Look at the chart. Thank you very much. Why? Why is it /24, please? Why? What octet are you looking at? You are looking at the fourth octet. The fourth octet determines if it's a /24 or is thank you very much. The last octet. Thank you, Mr. Ebenezer. That's the answer. So if there's a number in the last octet, it's a /32. Somebody asked me this during the week. If it's a, let me ask you to 10.12.0.45 /24 or /32. What's the answer to this? 10.12.0.45. Anybody else? What's the answer? /32 or slash? That's true. Yes, it's a /32. Why? We are looking at the fourth octet. It's not the third octet, not the second octet, not the first. The fourth octet determines the CIDR and the subnetting. So what is subnetting? I believe you can see my screen. It is the modification and breakup of the IP address. So on a slash 24, you are allowed a couple of more IP addresses. If I have a slash 24, that means slash 2, slash 4, slash 8, that's on the fourth octet. I mean, dot 4, you get what I'm saying? That when you have a slash 24, you are allowed other IP addresses. Slash 24 means that other IP addresses can. So let's say you have a party in your home. I've given that example before. You have a party in your home, maybe a birthday party, I don't know, baby dedication, whatever it is, and you have and 15 people come to your home. All of them will have access to the internet if they are using your Wi-Fi. Why? Because the internet company is going to assign like a slash 24 to you. Hope that makes sense. So that as many people that come to your home, they can use your internet. Hope that makes sense. So if I'm your internet service provider, I can assign to you, look at the chart, I can assign to you maybe 34.45.67.0 slash 24. So if I come to your house as a guest and 10 other people come to your house, maybe they will have something like maybe 192.0.34.56. Then another person can have 192.0.34.58. Another person can have 192.0.34. I don't know, 12. But this is the private IP address. What will happen if I'm trying to go on the internet in your house? What needs to happen for me to go from a private IP to a public IP address? Please put it in the chat. What needs to happen? Quickly, that you should know that what should need to happen if I'm going from a private IP to a public IP address. Thank you, NAT. Network address translation. It will NAT it. It will NAT me from the 192.0.34 to the 34, the first part, dot 45. That's what is writable on the internet. It will NAT it. You get what I'm saying? So subnetting determines the logical ways to subsection IP addressing. Hope that makes sense. That's subnetting. Why is it necessary? When is subnetting necessary? When is subnetting necessary? It is required for your network. It is required for your network. So it helps to distribute network across multiple LAN segments. It helps to distribute across multiple LAN segments. It helps a lot. It helps a lot. It segments local, the segments need to be localized for network management. I don't all these details. Just go and watch videos on subnetting. So it breaks down your network. It breaks down your network. That's subnetting. It breaks down your network to increase latency and broadcast domain. It breaks down your network so that, I mean, if I come to your house now and the ISP only assigns the first part, the 34.45.67.0, we can't, no, dot 0, dot 10. It can't do that. The ISP, internet service provider, that's ISP, cannot assign a slash 32. It cannot. It can't because it's going to be confusing. That means only one person can access the internet. If somebody comes to stay in your house, they come from Africa or they come from somewhere to stay in your house for 2 months or a month, they will need access to the Wi-Fi. If you have 3 laptops and 2 iPads and 2 cell phones, everything will need access to the internet. So that's why we have more private IP addresses, and all of them will NAT to a public IP address. I hope that makes any questions. Yes, it allows you to access the internet. That's nothing. It allows you to access. So subnetting breaks it down. It makes it more routable. So that's what subnetting does. It pretty much modifies and breaks up single IP addresses to help logically, route things. So your router can subnet the IP address to give it a logical way of accessing the internet. I hope that makes sense. All right, let's keep it moving. I even have other things to do today. Oh, Lord. So now we're going to look at binary numbers for IPv4. So, just understand this now. It will be confusing in Jesus' name. Just, just understand it anyway. All right. So, we have 128. Look at that place value. Just learn those 128, 64, 32, 16, 8, 4, 2. We have 128. I believe you can see my screen, please. 64, 32, 16. You can see my screen. Oh, wow, 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 wow. Oh, wow, I'm surprised. Okay, let me close this. Um, can you see my screen now? Yes or no, please, just let me know.
Yes.
Yes. Okay, 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 cool, cool, cool. Just making sure. So we have so for IPv4, you have a binary system, and we have, just look at the place value: 128, 64, 32, 16, 8, 4, 2, 1. Just remember the place value. Now, to be honest with you, we have we have calculators on the internet that can calculate anything for you. So all this is just the manual process. Actually, when I work some things, I'll just I have something saved on my tab. I click on the calculator and it helps me to calculate things. Hope that makes sense. So 192, 128, 64, 32, 16, 8, 4, 2, 1. You get that? So we have ones and zeros. Ones and zeros. So each computer has a binary system. Now, this is you are going now into we are going into the weeds now. Each computer has a binary systems. One means on, zero means off. One means on, zero means off. Hope that makes sense. So I'm trying my best to put it in such a way that you understand it. In every network, the first address is a network address. The last address is the broadcast address. So if you have four domains, four octets, excuse me, the first is a network address. The others are broadcast address. Let's continue. Now, we have four octets. Am I right? Four octets. So each octet has 8 bits. You remember I mentioned that last week. Each octet has what? 8 bits. So 8 signifies 255 in the network mask. Hope that makes sense. Just don't look at the other stuff so you're not confused. So 4 octets, look at the chart. I put 4 octets in the public IP address. You have 4 octets, and each octet has 8 bits. If you count all the bits, it makes 32. That's why when the fourth octet is occupied, that's slash 32. I hope that makes sense. If the fourth octet is not occupied, it has a zero in it, is a slash 24. Why? Because 8 times 3 is what? 24. 8 plus 8 plus 8 is what? 24. I hope that makes sense. That for every 4 octets, you have 8 bits. Let me give an example in the chat just to um, give us. Okay, let's say we have 10.0.0.0. Let's do 10.10.0.0. What is this? Slash. So what is it, sir, Mr. Nido? If it's 8 bit per octet, what slash is what cider is this? Slash what? Please, people should know this. It's a slash 16. Slash 16. We have 8 bits. 8 bits. So 8 times 2 is 16. 8 plus 8 is 16. So that's a slash 16. If I do 10.0.0.0, what is this? Slash 8. We only have 8 bits. Hope that makes sense. If I do 10.14.56.78, what is this? Thank you, slash 32, because each of the octets, 8 times 4, 32. 8 plus 8 plus 8 plus 8 is 32. So it's slash 32. It's just to buttress, I think you should know this one. 10.56.0. What's this one? Slash 24. Why? Because 3 of the octets are occupied. 8 times 3, 24. Or 8 plus 8 plus 8 is what? 24. So each octet has 8 bits. Now, for the network mask, each octet is 255.255.255.255. What is this? Is it a slash 32 or slash 24? Let me just ask. What's this? This is the that's what we are going to now. That's the subnetting that we're looking at. Thank you. Why? Because all of the octets are occupied. Hope that makes sense. Hope that. So now if you see 255, there's an example. What is this? Please, everybody should answer this very quickly. This is slash 24. Why? Why? Because 3 are, so that's the same thing. So if you have 10.14.56.0, this is a, I'll just put in chat, give me a second. And if the other place it is 255.255.255. That's how it is. So the subnet mask is that what you see, the bottom part. The cider is slash what? 24. The subnet mask is the 250. I'm just giving an example. We'll still check the slide. Is this possible? 10.0 that's 25. Yeah, it's possible. It's very possible. It's possible. If that's the case, what would be the subnet mask for that Mr. Nido posted? What's the subnet mask for that one that he just posted? The subnetting is a slash 32. It is. Because the fourth octet is occupied. That's the cider. Cider is a slash slash. So when I talk about cider, CIDR, some look up the full definition of it. CIDR is what you see as slash 32 slash 24 slash 16 slash 8. That is a cider. CIDR. It's classless, something, something. Get the definition and put in the chat if you know it. CIDR. Now, when I talk about subnet mask, it is the 255.255.255.255. That's subnet mask. Hope that makes sense. Please, this we are going to build on top of it. So I want you to understand this before I continue. That cider, CIDR is the slash 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 D slash 8 slash 16 slash, that is cider. Is occupied. Yes, sir. Yes, sir. Yes, sir. What you are looking at is for any IP address is the last octet, the fourth octet is the main one that you're looking at. If it keeps going down, you are having more IP addresses. So you keep having, so let's say it is 0000. More, this one, let me ask this question. This is a trick question. What is this? 0.0. What is this? What is this? 0.0.00. What is that? It's the internet. It's the internet. If there's zero, that's, I mean, there's no block anymore. That's the internet already. If you see 0.0, that's the internet. 0.0, there's no cider there. There's no slash. It's just the zero. Thank you, sir. It's the internet already. Thank you. Thank you very much. All right. So let's keep it moving. Share screen. So subnet or the network mask. See that. So you know that we have 8 bits per octet. You know what I'm talking about. So each 8 bit is 255. Everybody see what I'm saying? Please understand this. Let me make it bigger. 255 stands for all of the 8 bits. So that's the network mask. So this is a slash 28 now, but if you look at the first octet, it is occupied. So it is 8 bits and it is 255. The second octet is occupied. It is 8 bits and it's 255. The third octet is occupied. It is 8 bits and is what? 255. The fourth octet is partially occupied. Is partially occupied. So we have 4 that are on and 4 that is off. If you go back, 1, look at the top part. 1 means on, 0 means what? Off. Hope that makes sense. Hope that makes sense. 1 means on, 0 means off. Please pay attention. So if you look at the binary equivalent, all ones show that the binary is there. 888, that's 24. Am I right? But this is showing 4 ones. That's 28. I hope that makes sense. Oh God, this give me wisdom on how to explain it. That will make sense. So 192.168.1.3, that is a slash 28. So if you count all the ones, it gives you 28. Oh, that makes sense. If you count all the ones, 1, 2, 3, 4, 5, 8, 8, 8. That I wish I could put my mouse so you can see it. So the first three octets, that's a slash 24. Am I right? But you look at the fourth octet, there are 4 ones. That makes it what? 28. 8 times 3, 24. Plus 4, 28. Hope that makes sense. So out of all of it, we have 3 octets that are fully occupied. And the last octet, the fourth octet, we only have 4 that are fully occupied. The 0 means that it's off. I hope that makes sense. It's easy. Don't be confused. Each octet has 8 bits. Each octet has 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7. That's the binary equivalent you are seeing at the bottom part. Each octet has 8 bits. So the first 3 octets, you said they are occupied. Am I right? So 8 times 3 or 8 plus 8 plus 8 is 24. But the fourth octet, only 4 of the binary or the bits are occupied. So if you add 8 plus 8 plus 8 plus 4, that is what? 28. I hope that makes sense. Look at the last one, the binary equivalent. If you add 8 plus 8 plus 8 plus 4, it is what? 28. So it is a slash 28. Now, the network mask, if you see in the chart that for each of the octets, if they are full, it is 255. I hope that makes sense. The second one is 255. The third one is 255. But 255 is not on the fourth octet. Why? Because only 4 is on. Am I right? 4 is on. If you now go back, God, I'm saying serious, I don't want to confuse you. So we have the last one. Only 4 out of the binary equivalent is on. So if that is on, so it is 28. We see how more examples going. So I just want to just get the drift that when each of the octet is occupied, in the network mask, it is counted as 255. If you go, for those that use Windows, if you click ipconfig, go on CMD, command prompt, put in ipconfig, it shows you your private, public, your network mask, it shows everything. If you use Windows, just type CMD command and now type in ipconfig. You will see what I'm talking about. So the first octet 255 is occupied. The second octet 255 is occupied. The third octet 255 is occupied. The fourth one, it is 240. Why? Because only 4 out of it is occupied. Now, if you go back to the link I sent to you, let me check that link again. If that link is on the chat. Can we go back to the previous ones? Let's see. Okay. I will repost that link again, but you should have it if you are. I'll put that link again here. That's it. If you click on it, just go on it right now, and you see that green. See that slash 28. Look at slash 28. Look at slash 28. See there. That's the example I just gave now. I hope you are checking the green chart, the IPv4 CIDR chart. Look at it. The slash, let me share my screen. Maybe some people don't have it. Let me just share my screen right quick. You can see it. Slash 28 is this one here. I hope you can see my mouse. You see that 4 bits are missing. Am I right? So that's why it's making it slash 20. So you look at the subnet mask is 255.255.255.240. Now slash 32. Let's look at slash 32 before we look at slash 28. Slash 32. What does slash 32 mean? It means that all 4 octets are what? Occupied. All 4 octets are occupied. And you look at the slash, the prefix. Each octet has 8 bits. 8 times 4 is what? 32. 8 plus 8 plus 8 plus 8 is what? 32. The subnet max shows it. For each 8 bits, you have 255, 255, 255, 255. Let me just open that before I start doing the slash 28 slide. Let me just look at the chart. So we have 172.34.56.78. We know that the prefix is a slash 32. Am I right? The prefix is a slash 32. The network mask is 255.255.255.255. Do you get that? Why? For each of the octets, 255 is like everything is complete. The 8 bits are complete. So if you look at bits, you have 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. That's 32 bits. If you count each one of it, it's 8 bits per octet. 8 times 4, 32. 8 plus 8 plus 8 plus 8 is what? 32. Hope that makes sense. That for every network mask, so this 1, 2, 3, 4, 5, 6, 7, 8 is equals to 255. Hope that makes sense. In the network mask. Hope that makes sense. Please, if you don't understand, just raise your hand. Let me attempt to explain again. Each 8 bit signifies what? 255 in the network mask. Hope that makes sense. Okay, let me give an example. 172.34.56.0. What slash is this? Slash 24 or slash 32? And what is the network mask? Answer that quickly, please. Answer that. You should know this based on the example I gave earlier. This previous example of slash 32. What's the answer? Just put the answers in the chat. Everybody. Mr. Ditayo, Mr. Ebenezer, Shola, Mr. Shola, Mr. Luashion, put the answers in the chat or raise your hand, anyone you want to do. Okay? Don't wait for somebody to answer. Answer. People are waiting for somebody to answer. What is the network mask? What is the network mask? Just based on how I represented it. Look at the first example I put there, 172.34.56.78. Look at the cider, look at the network mask. What is the network mask for slash 24? Let me even double check as you guys are doing your own. Please answer quickly. Quickly. Thank you, Ebenezer. Mr. Nido got the first part. And okay, the second part too. Is a slash 24. The network mask is what? 0. Why? Because 255 represents each octet. Hope that makes sense. Each octet has 8 bits. If every bit is complete, it is 255. So the last one, 0, there's nothing there. So what is that? It's 0 on the network mask. I hope that makes sense. Please, you don't understand, let me know. This thing, we are beating on top of it. That's why this is the hardest part to learn. That's why I want you to understand it. Hope that makes sense. Look at the chart again. The first example I gave there is 172.34.56.78. That is a slash 32. And you look at the subnet or the network mask, it is what? 255.255.255.255. Why? For each of the 8 bits complete, it represents 255. It's just a formula. It represents 2. So if everything there is complete, it is 255.255.255.255. Hope that makes sense. Now, the other example I gave, the 172.34.56.0, that's a what? A slash 24. And the first 3 octets are complete. The last octet is what? A 0. So if you look at it in the subnet max, 255.255.255. What? Dot 0. Hope that makes sense. Let me give another example. I need you to answer. Please be involved. So 34. No. Give me the prefix and the network mask. What's the prefix? If you know the first two, you should know this one. Slash what? What's the prefix? Slash what? And what's the network mask? Mr. Shola, I've not heard anything from you today. Thank you, Mr. Nido, slash 16. Thank you, Mr. Ebenezer. That's it. It's a slash 16. And what is that? 255.255.0.0. God bless you. That's it. Hope that makes sense. So you are not confused that each 4 octets has 8 bits per octet. You count all the bits, it makes the slash 24 slash 16 slash, you get the point. If all 4 octets are occupied, it's a slash 32 because 8 times 4 or 8 plus 8 plus 8 plus 8 is 32 bits. For each of the bits that are ones, each bit is a 1, 1, 1, 1, 1. It is 255. So for each bit or each octet having 8 bits is 255. So 255. 255. Hope that makes sense. Last example, and I think we'll round up for today. I think I've tried for today so that at least you can grab this one and we can build on top of it. So we start doing slash 28 slash this one, you can just build on it. So if you do, let's do 172.0.0.0. What's the prefix and what is the subnet mask? What's the prefix? What's the subnet mask? Quickly. Sorry, I'm saying quickly. Please, sirs and ladies and gentlemen. We all do, don't worry. Just go watch videos. That's why you have YouTube videos. Just watch videos. It will explain it to you. /8. Thank you, Mr. Nido. Anybody else? What's the answer? Thank you. That's it. /8. Why? Because only one of the octet is what? Is occupied. Hope that makes sense. Oh, please, I hope you understand. The first octet is occupied and is 8 bits. And 8 bits stands for what? 255 in the network mask. So based on what you see there, it is 255 and this is .0.0. What? .0, which is a /8. I hope that makes sense. I believe that you understand this. We are going to build on all of it. So you start doing /28 slash I don't know 20 22 whatever it is, you can now build on that. But if you can understand this one, then the rest should be easy. I hope this makes sense. 4 octets, 8 bits per octet. All 4 octets occupied is a /32. All 3 octets occupied is a /24. 2 octets occupied is what? /16. 1 octet occupied is what? /8. Each octet with all the 8 bits signifies 255. 255.255.255.255 if that's the /32. /24. 255.255.255.0. Hope that makes sense. /16. 255.255.0.0. /8. 255.0.0.0. I hope that makes sense. Just check the chat. All the examples are in the chat for /32, /24, /16, /8. Assignment. Go watch TCP handshake that I mentioned. What is TCP handshake? SYN, ARC, and ARC. What is SYN? Client server initiating to a destination server. Hello, how are you? Destination server says, I am doing well. What do you want? Then the last part, ARC. I want to send this packet to you. Receive the packet. You get the point. Then watch videos on subnetting. Hope that makes sense. From these examples, I think it is very straightforward. That is not. You can tell that IT is not that difficult. Just understand the concept. Now, there are some places where you have to crack your brain. Don't get me wrong, please. But at least for this foundational stuff, I hope you understand what we are doing here. If you don't understand, raise your hand now, or forever hold your peace like marriage. All right. Thank you. God bless you. I think we'll stop here for now.